Yeah, and thanks, Ron. And just one other piece is like just to kind of link up what Candice just talked about from an ML ops point of view. She talked about how SageMaker can be leveraged for ML ops and went through the detailed steps. You can also leverage Kubernetes for ML ops, leverage integrating with SageMaker as well as things like Kubeflow, for example. Right. So the Kubernetes is a very powerful environment, and yeah, multiple usages, and definitely it has its its use in ML also. So just wanted to put it out there. It's a nice segue into what I'm going to talk about. So hello everyone. My name is Ramesh Dwarakanath, and I'm a principal solutions architect at AWS. Thank you all for joining this session, where I will discuss what EKS Blueprints is all about, right? And how it can help you with some of the challenges of building a complete Kubernetes cluster in a secure, scalable, and quick manner. This session, we'll talk about the common challenges that customers face with the Kubernetes cluster creation and management, and how EKS Blueprints addresses that. Due to time constraints, we will not be diving deep into the specifics of the implementation itself, but you can always reach out if you need more information on that. All right, so you are all here because you have chosen Kubernetes to run your containerized applications, right? So you probably all well aware that Kubernetes is a very powerful and extensible container orchestration technology that allows you to deploy and manage the containerized applications at scale. The extensible nature of Kubernetes also allows you to use a wide range of popular open source tools, right? We commonly refer to them as add-ons in the Kubernetes clusters. With such a large number of tooling and design choices available to you, building a tailored EKS cluster that meets your application's specific needs can take a significant amount of time, right? It involves integrating a wide range of open source tools that as you can see on your screen, and AWS services, and requires deep expertise in AWS and Kubernetes. So that's what usually leads to customers asking the question, now what? Right? What tooling and configuration should I use to run production workloads on my cluster? So let me first start by, try to describe the journey most of us have gone through when we decided to use Kubernetes. As always, right, we start off with the Kubernetes documentation, understanding every component in the system, and there are quite a few components. We understand the benefits, flexibility, and the features it provides, right? So we get all that. It solves our problem. It's extensible. It's configurable. It's all great. But pretty fast, right, we come to the conclusion that it also involves complexity for provisioning, managing, upgrading, securing, and scaling the cluster itself, right? We talk about things like, so we have a control plane and a data plane, right? So in a control plane itself comes things like, how do you enable HADR? How do you make it more resilient? The etcd, which is the data store for the cluster configuration. How do you manage the backups for that, and so on and so forth, right? Kubernetes comes out with approximately 3 releases every year, and keeping up with the releases so that you have to keep up with those releases, because you don't want to be out of date, right? You don't want to be on an unsupported version and get into trouble, right? It's an extremely critical job, right? And needs deep knowledge of Kubernetes, but does not add any business value, right? What I mean by that is, like, you need to run a Kubernetes cluster. It is very critical for your applications to run, but just running or managing the control plane or data plane or some of those infrastructure pieces, right, is not necessarily directly adding any business value. What you want to be doing is running applications on it, running your own business logic specific to your organization, and running it in the Kubernetes environment, right? So at the end of the day, right, we want to have technology to be an enabler of business with minimal effort. That's really what our goal is. So this is really what EKS looks like from an infrastructure setup perspective, right? So that is where, we talk about all the complexities. We talk about also, just to kind of add what we do from an infrastructure point of view behind the scenes is we have this, our control plane that is managed by us, AWS, and then we have the customer managed data plane, which is really where your stuff runs, right? Where your applications run and so on. So the control plane itself is spread across three availability zones. It has multiple API servers, multiple etcds, and so on and so forth. So you can see that there is a fairly robust infrastructure and highly available, resilient infrastructure that we build as part of EKS, which is really the managed Kubernetes service. So in the end, with EKS, the complexity of standing up your own Kubernetes control plane is simplified, right? Instead of running the Kubernetes control plane, which you just saw, the three availability zones and multiple API servers, etcd, and so on and so forth, you connect to a managed Kubernetes endpoint, right, in the AWS cloud. This endpoint abstracts the complexity of the Kubernetes control plane, and your worker nodes can just check into a cluster, and you can then interact with your Kubernetes cluster through the tooling, for example, kubectl, that everybody deals with, works with and loves in dealing with a Kubernetes cluster, and just leverage the same tools, right? So now the next step is really the worker nodes, right, for our pods to run. Now, provisioning single instances as data plane doesn't really scale well, right? And nobody really does that. So in order for that, we have features such as EKS managed node groups, which provides great value, right? It automates the provision and lifecycle management of nodes. It has a variety of features such as, spot support and interruption handling, multiple instance type support, auto labeling nodes with needed labels for cluster autoscaler, incremental or batch upgrade. Spot instances, in case people may not be completely aware of, is really the excess compute capacity that we have that is given to our customers with significantly lower costs than the on-demand instances. But the caveat there is that they can be recalled anytime in case there is a need to use some of that excess capacity. So it's not necessarily for every workload that you want to use spot instances, but it has definitely some very, a lot of use cases that you can leverage that. But it does not end here, right? So we have set up the cluster, right? And we have, our cluster is all set up. We are managing control plane. We are using EKS, so it's all good there. But then the next step is to configure, deploy, and manage cluster-wide add-ons for different needs, right? So things like basic operational services, core DNS for service discovery, VPC CNI for pod networking. From an observability perspective, CloudWatch container insights to get the details around the pods themselves. FluentBit for log shipping, Prometheus agent to scrape the logs from your application and from the containers themselves. Load balancing, AWS load balance controller, Nginx ingress controller, and so on, right? For GitOps, right, to enable GitOps, we have Argo CD. For other operational add-ons, we have for things like secret store, external DNS, cert manager, and so on, right? So there's a lot of stuff, a lot of add-ons that you need to now deal with and configure to this cluster. And next, then we need to be able to design our cluster to support multiple teams and users. Like there is no one team, there is no one set of users, right? Every organization has different types of users. They need different types of access, and we need to be able to provide a standard way for that identity and access management. We should be able to implement policies based on team responsibilities and requirements. And in the end, we should be able to provide an isolated logical separation, right, in the form of namespaces and permissions for multiple applications to run in a single namespace. Those are all kind of leveraging the underlying, concepts that Kubernetes provides, and to be able to integrate that with, the identity and access management. And the final step is really kind of automating the creation of the clusters with all of its configurations across environments in a single pipeline with everything that we have discussed so far, right? So all of the pieces, the cluster itself, the add-ons, and the IAM pieces, right? All of that to be put in automated, right? In a nice way. And we would want to use an infrastructure as code tools to programmatically describe the configuration, right? That's really what makes it powerful and repeatable. So just to kind of summarize the challenge that we have, right? So what are the challenges? How do I enforce standards and best practices across clusters, right? How do I create boundaries between application teams? How do I ensure the add-ons dependency is satisfied so we will have all the relevant add-ons installed to support our configuration? How do I add new EKS-based environments, with a few lines of code, right? And how do I use a single source and tooling to configure everything that we discussed so far? I mean, all of these are important challenges. All of these are challenges that everybody has gone through this. Whoever has tried to set this up, tried to scale out, right, runs into these challenges. And it's very, very important, right, that we solve these problems. So the question now comes, okay, now we have listed all the challenges, right? How do I get there? What do I do, right? And this picture kind of gives a good view of, how do I get from the left side to the right side, right? How do I build an EKS environment without ending up with a configuration mess, right? How do I build an EKS base environment that is all tied together and provides more value than a single component, right? That a single configuration provides on its own, right? The AWS customers, right, are trying to solve this problem by building internal platforms to tame this complexity, like automate the management of their Kubernetes environments and make it easy for developers to onboard their workloads. So everybody recognizes this problem and they are coming up with their solutions, right? However, these platforms require investment of time and engineering resources to build, right? The goal of this project is to really provide of the EKS Blueprint project is to provide customers with a tool chain that can help them deploy a platform on top of EKS with ease and best practice, right? Ultimately, at the end of the day, we want to help the EKS customers accelerate their time to market for their own platform initiatives. That's really the end goal of this. Right? So this is exactly what EKS Blueprints aims to provide, right? EKS Blueprints is an open source development framework allowing you to programmatically build and maintain EKS environments using infrastructure as code, right? And so what, if you look at this, right? So it is basically set up with infrastructure as code, and we are leveraging either Terraform or CDK, and we'll go through that a little bit more in detail. We are basing it on what we have learned from our past experience, right? What AWS has learned with that best practices and recommendations. It's integrated with all the popular open source Kubernetes tools and services, right? That is kind of the essence of all that. We saw that those add-ons are a powerful complement to the Kubernetes cluster, and which is why a lot of times people choose Kubernetes is to leverage those open source tools. And finally, it is fully extensible and customizable. You can add your own add-ons. You can create your own add-ons. You can, set up, so our third-party partners and all so on can add their own add-ons. So you can make it however you want it. You can remove, add, whatever fits your application. So when you start with the basic components of EKS Blueprints, it's really cluster and compute capacity, right? That's kind of the foundational piece that starts off, and it includes the Amazon EKS cluster configurations, such as cluster versions, control plane logging, data, and then as well as data plane setup, like things like, Fargate or managed nodes or any custom combination thereof, right? And we also have leverage BottleRocket, and BottleRocket is really a Linux-based open source operating system that is purpose built by AWS for running containers, right? So Bottleneck includes only the essential software required to run containers and ensures that the underlying software is always secure. So you can reduce your maintenance overhead and automate your workflows by applying configuration settings consistently as nodes are upgraded or replaced when you use BottleRocket. So next is the cluster add-ons, right? So you created your cluster. Now you're putting all the add-ons on top of that. And at the time of this session, EKS Blueprints provides configuration for for more than 25 add-ons. And it's always getting updated. It includes AWS specific add-ons such as load balancer, VPC CNI, and also community-based add-ons like a cluster autoscaler, Nginx, Argo CD, right? And then we also have finally the partners and third parties that create their own add-ons. Partners like Datadog, Dynatrace, HashiCorp, KubeCost, and so on get overlaid on top of that. And then finally, you have your blueprints, which includes cluster access and permissions management for users, roles, or groups. This is being abstracted to the user in the form of a construct, what we call as team, right? So team is designed to provide a set of isolation boundaries between applications deployed in the cluster. And if you want to allow multiple teams to run workloads in the same cluster, EKS Blueprints provides an approach for enabling soft multi-tenancy, right? So as defined in the EKS best practices guide that people may have already seen, soft multi-tenancy leverages native Kubernetes constructs, things like namespaces, roles, role bindings, cluster bindings, network policies to create logical separation between tenants, right? But if you have a hard multi-tenancy requirements, such as a SaaS provider, right, you would need to run completely isolated workloads for different customers, right? So in the end, this is what is an example of an architecture diagram that represents an EKS environment that can be configured and deployed with EKS Blueprints. This diagram illustrates an EKS cluster that is running across 3 availability zones, is bootstrapped with a wide range of Kubernetes add-ons, as you can see there on the screen, and hosts workloads from multiple different teams, right? The EKS Blueprints configure and manage the users and teams who have access to a cluster. So it is a platform team. So it's divided into either platform teams where you have access, those set of users have access to the whole cluster, right? Or pretty much for admin activities, type activities, or namespaces within a cluster, which are really divided into set up as application teams. So you have different namespaces and you're only focused, you have your role only aligned with those namespaces that you have, right? And if you want to leverage a GitOps based approach to managing both cluster configuration and workloads, you can use EKS Blueprints to bootstrap a cluster with Argo CD, right? And any number of Argo CD application resources, and kind of leverage both the cluster configuration as well as the workloads themselves. So Blueprints uses 2 popular IAC infrastructure as code tools, the CDK and HashiCorp Terraform. The Terraform repository that I show here contains a collection of Terraform modules. This project leverages the community Terraform AWS EKS modules for deploying EKS clusters. The CDK repository contains the source code for EKS Blueprints NPM module, right? Both can be used by customers, partners, and internal AWS teams to configure and manage complete EKS clusters that are fully bootstrapped with the operational software that is needed to deploy and operate workloads. Yeah, although it's not a CDK session, I just wanted to go quickly mention what CDK was. CDK is really a cloud development kit. It's a code framework to create, maintain, and secure AWS cloud resources. And then it automatically translates into a cloud formation stack under the covers with all the relevant configurations that are built into those stacks, right? So some of the advantages of using CDK are it's a high-level construct with best practices defaults built into it. You can use your own programming language and use CDK. You can use software development methodology and tools, and then you can connect all your AWS resources across even stacks, different cloud formation stacks. So to summarize, EKS Blueprints provides the ability to configure and deploy EKS clusters and its compute capacity You can replicate them across environments, integrate into existing VPC, automate cluster operations using automatic pipeline that is triggered upon every commit, right? It provides a full lifecycle management for add-ons installation, upgrade, retirement. You can perform validation of the add-ons dependency, so you're sure that you have the right add-ons for your configuration, and then it provides all the relevant AWS resources, essentially the IAM roles for service accounts for add-on functionality to be able to leverage that with the Kubernetes cluster. For team management, it provides, again, clear separation between application teams, as well as supporting permissions for team members and roles themselves. And finally, you have for application delivery, it provides GitOps tooling, which is kind of really where the industry is going, and where people are trying to manage not just their application infrastructure, but also not just the application configuration, but also the underlying infrastructure. So you are able to leverage that to deploy workloads using GitOps methodology and manage them across multiple clusters in multiple environments. So if you want to know more about EKS Blueprints, here are some of the resources that are available. There are a lot of resources available. There is a lot of code available already. There is a lot of examples. There are patterns and so on. So if you take, you can very easily get started and actually build out a working EKS cluster pretty quickly. So I would definitely encourage people to go in there and start to play around with it. And you will see that it has a lot of value, and you can easily get that value and see that value. So finally, that's where the end of the presentation. Thank you so much for attending this session. I hope you learned something new and useful today, and you'll start leveraging the available code and documentation on EKS Blueprints to create your own complete EKS environment. Thanks.